Hi, my name's Neil Scott. I'm the head of data engineering and data operations at Aviva. And we're here to talk to you about a migration that we've recently completed. And by recently, we flew out from the UK on Friday, and the system that we were migrating from was shut down at 1 o'clock Saturday morning. So this would have been a completely different speech if the migration had failed, because I'd be telling you about all the bad things that happened. But it completed, so we can carry on with the original plan. For those that don't know, Aviva is the largest insurance company in the UK. We also have, we're a global insurance company, so we've got markets in Canada, we've got in Ireland, and really this is the movement to Snowflake's been the culmination of a very long journey to Snowflake that started almost 5 years ago. But we'll talk about this migration, which is moving the main part of Aviva's data analytics and AI estate over to Snowflake. Aviva is it's a multi-platform system, and it's also a composite insurer. So that means we've got markets from your traditional life and pension insurance, motor, home, travel, and all the way up to our large corporate customers. So it means we've got a very diverse workload, very diverse portfolio, and a very challenging market to work in. We'll also be hearing from Bob from Snowflake. Today we're going to talk about really what we did in order to get there and how we did it. And there's also some lessons learned as part of it. So the agenda is roughly, I'm going to talk for a little bit and explain to you about what Aviva does and what we were trying to do. And then we'll talk about the accelerators that Snowflake really brought to us to enable this to happen in a very, very short time frame. One of the things that we recognize at Aviva is we are definitely entering a new era. And data, we've heard the saying for a number of years, data is the new oil. Data is now a currency. If you don't have good data, you are going to struggle to be competitive. One of the things we are focusing on is how do we harness the power of that data? Because if we don't, we will struggle to compete. And what we are looking to do as an organization is use data to build better products and better services for our customers, but also the way our customers want to interact with us is changing. 10 years ago, everybody wanted underwriters, and you'd have lots of offline journeys and telephone calls with your insurance companies. Now, if you have an accident, it's all done on your phone. You're very unlikely to want to talk to somebody. There's a very digital generated journey, and that requires data. One of the things we also recognize is AI is a big thing. For insurance companies, for financial services generally, AI has huge potential. But one of the great challenges with AI is you can't, and everybody says it, you can't have a great AI strategy without a good data strategy. And a good data strategy isn't one thing. It isn't just data quality. It isn't just having your Gen AI processes, your visualization, your data science working. It's you've got to bring it all together. And we had a lot of data in a lot of different platforms. So what we did a very long time ago, 5 years ago, is we built a Snowflake platform on what we called the model for how a modern insurance company should work. Aviva is a very, very large company. We've been built up over many years through large acquisitions and mergers. The original Aviva, as it was set up 327 years ago. It looks very different now than it was then. But we also have some very old systems as part of it. We have mainframes. It's that old. But we also recognize that we can't compete in a modern world without modern technology. So our challenge was we had more than 3,000 users that we needed to migrate. And these weren't just like a BI user. Our BI users was one user, which would feed all the business objects, for example. These were data scientists, these were actuaries, these were analysts, these were people creating large amounts of data. In order to service them, we had over 10,000 data pipelines running, loading data from all across the system. Tens of millions of rows of data, tens of billions of data items add to the system every single day. We have over 1,000 machine learning models that are actively supporting our customers getting a price, deciding if a claim is fraudulent, supporting customers through the life cycle. And that's already underpinned by 1.6 petabytes worth of data. The biggest challenge we had in this is that when we came up with the idea of doing it, we had a hard deadline. It had to be off in 17 months. 17 months from when we went, let's do this. And that resulted with me and my boss sitting in a room with 17 months, a chunk of cash, and no plan to get there other than a deadline of the 1st of June. So we did a little bit of research to work out, how's everybody else done this? What do we need to be thinking about? And we realized that not many people have actually attempted this kind of scale movement on the timelines, especially from a cold start. And we also recognized that we needed to build a team around it because we didn't want to close our eyes and hope. We actually wanted to focus on bringing in the best people. So this is a very high level. When I asked the program manager to produce this, he said there was a lot more detail in it, and it was scary how simple it was. But this is broadly how we worked. We split our year into 6 phases. And from sitting in a room with 2 people, we originally went, we need to move the project scope, the partner selection, and the technology selection. We already know we're going to Snowflake, but saying you're going to Snowflake is the easy part of it. How do you get your data, 1.6 petabytes worth of data, 10,000 data pipelines, 3,000 users, all with their own data processes. Some of them are lovely and augmented in Git, and we can version control them, there's beautiful. And some of them are stored on network drives, and they change them very regularly. And as we found out later on, some of them, especially with data scientists, you move them over and they go, oh, I finished doing that last week, I'm now doing this that we haven't moved. So it was a real challenge. Phase 2, or Q2, was all about designing the platform, onboarding our partner, and onboarding the technology. We are a regulated industry. We are financial services. So the cybersecurity controls of bringing any technology into our estate are immense. Anybody who's worked with Aviva, and I've spoken to a few people already here today who are working with Aviva, say we have a very, very detailed cybersecurity team, and they are very, very detailed in their pulling apart of the technology to understand it. Q3, we built out the technology, and we really focused on that point in getting Snowflake. So in October last year, we hadn't moved any data. We hadn't moved any people. We hadn't even started. All we'd actually done is selected our partners, brought on the technology, got it all set up, and told 3,000 people, you need to move all your processes over, told all the BI teams that you've got to repoint your BI apps, and then make sure your end users aren't impacted by it. So one of the most important things we did was we had to get the right partners. So we spoke to Snowflake, and we basically said to them, if you were going to do this, how would you do this? Because, like I said, when we looked at this originally, nobody had really done this on the timelines we're looking at. We at Aviva are very good at doing large migrations, but they take many years, and we didn't have the time to do that. So we brought in Snowflake Professional Services, which Bob will talk about their engagement in this and what they did. And that was very much around moving 1.6 petabytes of data over a network from one cloud provider to another cloud provider in a realistic time. And the bigger challenge was not just moving 1.6 petabytes, the data in the source would change. So we need to also keep it in sync, because while it's being tested over here, it is operational over here. So 1.6 petabytes of moved data actually culminates in a lot more data that actually had to be moved and synced over the life of it. The other thing we had is we had 10,000 data pipelines, 3,000 users with all their own scripts that all need to be converted. So we were on a SQL platform before, we were on Oracle, and actually Oracle SQL to SnowSQL, it is very similar, but you also can't drop 10,000 pipelines into Snowflake and go, it will just work. Working with a partner and finding somebody to do that, we could pass the code over to, they could convert it over, they could convert all the objects over, so changing the metadata between what it looked like on Oracle and what it looked like on Snowflake. And we as an organization didn't have to have those skills ourselves, was a huge enabler. If we tried to do this, we would have been here in Summit 2027 and still said we are ongoing. Having the right team has been fundamental to the success of this. And we've started to do some deep dives on why this has worked so well, and that team has been vital. And this is a high-level plan of what we did. We brought in and we put the data migration tool, and then we had our data ingestion processes running. Now, code conversion, it sounds simple. Trust me, it is not, because IT teams, our data engineering teams, they're one thing. We had some legacy processes that had been built over many years that were fundamental to the organization working, but they were very tricky to migrate. We also had some real guy who wrote something about 15 years ago that he thought was amazing and then bit him in the butt, because there was a lot of dependencies built on an application that I wrote when I was an engineer a very long time ago. And it was a real pain. It did not convert to Snowflake very well, and needed to be completely re-engineered. If we'd had to do that in-house, we'd have never got anywhere near it. But working with the Next Pathway, what they managed to do was take that application and run it through their automated tooling and turn it back over to us far faster than we'd ever been able to rewrite it. And we found many of these key pieces of capability that had been built up and built on over the years. And what it really gave us the ability to do is start to pull those pieces apart, gave us the ability to understand what was going on and get them back to us. So our phase of migration was we moved the data over, Next Pathway created all the metadata, Snowflake moved all of the data from point to point. We then handed that data over to our end users. They then started to UAT that. And anyone who's done UAT with end users will know that it is very, very painful. It's not like working with testing teams, pricing people, analysts, actuaries, data scientists. They're not designed to coding best practices and all these wonderful things. Do you have test data that you can start to go on? So we spent a lot of time syncing the data back over to keep the other things working. And then on the right-hand side, what we managed to do is repoint people onto us using Snowsight instead of the tools they were using before. The data scientists, we repointed all of the ML and AI tools that we have in Aviva, got the models running, built them all up, and we're testing them out. Same with our pricing engines, our pricing services, they're all now running off Snowflake. And all of this gave us the ability to have a consolidated platform which took away a lot of the pain points we had. So I thought this graph was quite interesting. The top right one is our number of 1,000 logins we had per day from when we started the project in September. And some of these peaks you saw was us just stress testing the system to make sure if we get 40,000 logins a day, which was our NFT peak, could we actually manage to do it? At the end of May, we were averaging about 35,000 logons to the system a day. These are majority of people. So these are people during the working day as opposed to machines connecting. There's a lot of people using the system throughout the day. On the right here, we've got the amount of data in our production and non-production data. This is just the amount of data being read every day out of the system. So by the end of May, we're reading about 375 terabytes worth of data is being accessed on a daily basis in our Snowflake platform. And it kind of gives you an idea of the scale of data processing that we're able to achieve now. We have a system in Aviva called Guidewire. For anyone who doesn't know that, it's a very, very big insurance platform for managing things like claims and policies. We had processes that we were running inside our existing system, and it was costing £7 on the existing technology to run. When we ran it in Snowflake, this was on a lift and shift technology. So Snowflake moved all the data over, got the data available, Next Pathway migrated the code, converted it so it ran. We saw substantial reductions in cost. The cost reductions are hugely valuable to the organization, but the time reductions are hugely valuable to our customers. Because actually, if we are now able to understand, as we end up doing, in just under 2 hours, what historically was taking us 4 to 6 hours to understand. It means we can do this multiple times. Pricing and analytic teams, fraud detection teams, all of these people are now able to get multi-day updates on positions of claims, rather than before they would get once a day. This enables us to combat fraud in different ways. It gives us opportunities, and we can do it at a cheaper price point. We just now get to choose what that price point is. We can have it in 30 minutes if we want to do it at a medium warehouse. And the reason why this is actually a very interesting one is it actually works out to be, because of Snowflake's linear scaling, cheaper to get it in 30 minutes than it is to get it in almost 2 hours, because of the way the system works. And we've seen many of these as we've gone through. The other one that quite often, I use this quote a lot, it feels like you're moving faster. This is a performance graph for Snowflake versus the historic system with doing an underwriter-led quote. And if you look at this, the high point is almost a minute and the low point is 30 seconds. These are for underwriters who are sitting down with customers and they're doing a quote. As an underwriter, you press, I'll do a quote to update it, and you have to sit there and fill for an unknown amount of time, because the system could work really quickly and you could get it in 30 minutes, 30 seconds, or it could take a minute and you've got to fill that. What we found with Snowflake, and please ignore the 2 on the left, I forgot to cache the warehouse because it's always running normally, but what we actually managed to get is it's 7 seconds. And that's where the underwriters are saying it feels like it's moving faster. It's not just it's moving faster, it's consistent. And they click the button, the little spinny thing appears on the screen. They say to the person, yep, we're just getting your quote, and it's here. Whereas before, we had lots of things in the screen to explain what was going on because there was this huge variance in the runtime. And all of this drives out to a better customer experience. So by moving to Snowflake, not only did we manage to reduce our cost, we actually managed to increase our customer experiences. So when we looked at this, we recognized very early that this is a multi-dimensional problem. It wasn't a problem that we were going to fix with people, process, or technology. We had to get them all right. Finding the right partner was key, because actually I've done these product migrations before, and one of the things that's been different in this one is actually every time we hit a bump in the road, and this makes it sound like we never hit a bump in the road, we hit a lot of bumps in the road. But by having the right people and the right team on the field, what that meant is everybody was looking for how do we get over this? How do we resolve this? The other thing is networking, and you can't do, when you're trying to move data between 2 cloud providers, you can't spend enough time on your networking, because it is literally the easiest thing to get wrong and the biggest thing that will slow down. You're moving 1.6 petabytes worth of data, more than that. You've got to physically move that. End user engagement early. Talking to our customers, we were talking to them 6 months before we actually turned up and asked them to do the very first thing. It got it in all the business plans. It got it in everybody's psyche. Everybody was aware it was coming. And what that meant was when we did actually finally turn up, yes, everybody also said they were busy doing other stuff, but at least we told them ahead of time and they were bought into the vision of where we were trying to get to. And the final thing, and my personal take on what made this so successful, is we did many, many, many small incremental achievements to build velocity. It's very easy to say, we'll do this thing for a sprint, and then we'll do this thing for a sprint, and then we'll deliver it. We had the other approach. We were trying to deliver multiple things in every sprint, because velocity built velocity. The more people we moved over, the more data we moved over. We had to support a split stack architecture for about 6 months, which was a pain. But because we were getting more people over, what we actually started to do was get demand for, I want to be moved next because all my data is over there, other people are seeing these benefits. Whereas if we try to do a big bang approach, it's very, very difficult to build that velocity. Small incremental improvements throughout meant that we were getting demand to be moved over and people competing to try and move next, as opposed to trying to force them over the line. So Bob, do you want to take them through?
Thank you very much, Neil. So I'm Bob Magley's, a Senior Solutions Architect at Snowflake. Been here about 3 years. As a little bit of background from me, I've been doing databases for more than 35 years. I've touched pretty much every form of database across multiple industries, et cetera. And what I want to talk about is DMVA, Data Migration and Validation Accelerator, which is a tool that we created. I'm one of the creators of this tool. But what you can see is the problem we had here at Aviva is they've got a lot of data, 1.4, well, the slide says 1.4. It's really over 1.6, probably even larger than that, because we did a lot of incremental syncs. 250,000 tables. Think about that. That's a lot of just metadata. And out of that, 150,000 of them were user-based tables. So the problem with user tables are they're uncontrolled. They're created in a minute, destroyed in a minute. You never know what's going to be there. So it needed that ability to be able to say, okay, hey, we've got to bring this thing back up to current state, but you can't move 1.4 petabytes or 1 point anything petabytes overnight. So it has to support incremental sync. It also, we supported multiple environments all at the same time, which is kind of critical because you want to be able to do that conversion work. You want to be able to have test data. You want to be able to resync your test data. I ran my test, I resync it, I bring it back. And all of that was also done on a pretty small environment. So you can see that the VM we run it on, and I'll talk more about what it actually is, but it was a 32 core, 128 gigabytes of memory. Not a monster box to move all of this data. It was done with 5 part-time Snowflake people. So we did not have outside people doing the work. One of the key parts that we developed this tool to do is take the work off of you. Let the tool do the work. Let your bosses be happy because they're going to get reports that says it's getting done in time. We know when it's going to be done because we know how fast it's moving. And it all does it on a very small amount of Snowflake resources as well. So we run on extra small clusters, and as you'll see in the presentation, the whole thing is very scalable. So we can upsize and downsize this as we need to over time. So what the tool is, the actual thing is a set of Python code. So it's a set of Python code. It runs on a Linux VM, typically. It sits in the middle between your source and Snowflake. And it also leverages a file system. All it's really doing is collecting a bunch of stuff from the source, stages it onto the file system in the middle, and then pushes it up to Snowflake. It does all of this in a nice pipeline flow basis so that it keeps on moving things. All of that totally scalable. We got too much load going on the Oracle system right now, drop it down. Okay, well, you've done your work for the day, we can raise it back up. It is designed to be able to run 24/7 over continuously, and you can adjust all of those things dynamically to help make that happen. So some of those key parts, as I mentioned already, it is very lightweight, so don't need a lot of stuff. You can even run it on your Mac laptop. It is Linux-based, or at least we only run it on Linux right now. So it doesn't need a lot of footprint to be able to run it. One of the other key parts is that when you're doing a migration of data that you want to come off of some system, the last thing you want to do is have to say, oh, I've got to go install some agent on your production Oracle box, and now I might mess up your stuff. Yeah, that's not going to go very well. So the tool is purposely designed to say, no, it is read-only on the source. We kind of operate like we're a bunch of reports. We queue up a whole lot of jobs, we submit them, and they do their work, and they do it in a continuous pipeline kind of fashion. I already mentioned that it is truly dynamically adjustable, that on the fly, you tell it, hey, back off. It will quiesce whatever work it's doing, bring it down to a new level, or raise it back up. All of that can be put on a schedule, can be controlled at will. It is very modular in that one of the things we do is we chunk up the data. And one of the purposes of chunking that data is twofold. One, you don't want to move a table that's got many, many billions or possibly trillions of rows in it and one big gulp. So in order to support that incremental load and to make everything work nicer, we have what we call grouped checksums. We pick some column to do our grouping of that data that we're going to chunk it on. And we'll do that in a way that typically is very performant on the source. So we'll leverage the indexes or the partitioning or whatever metadata we can collect out of that source system to say what is an efficient way to break this data up.
I was one of the
So we do
talkers,
that
but
in order to minimize how much workload we put on that source system.
I didn't want to interrupt him.
And then we can also manage how we're going to map that. So we had to bring data from multiple systems to one Snowflake account. So in doing that, you're going to potentially change the names as you bring them across from the source system to the target system. We have we call them mapping rules that says, you know, I take database X on source Y, and we call it, you know, database X _ dev on Snowflake, so that you have those different things. And of course, as I mentioned, you want to make your bosses happy. You want to know what you're doing. You want to be able to track what you did. So all of this stuff has dashboards. And we now even have a Streamlit front end that allows you to quickly do all of this work graphically and see it all, filter it, and juggle it as you wish. So what does migration actually look like? So the first thing you got to do is obviously define your plan. So you need to figure out what systems am I coming from? What databases on those systems are we going to bring over? And what databases, schemas, and maybe you even want to exclude some stuff. So all those things are capabilities of DMVA. So the ability to say, hey, here's all the stuff that's there. As I mentioned, remember those 150,000 user tables? Well, one of the things you need to know is what was there yesterday when I looked and what's there today when I looked. How are they changing? And to be able to deal with that change. So you define that up front. We then kick off the extraction processes. It goes in, it grabs a count and a checksum of all of your data on that source. It brings those into Snowflake, and we now use that to say, we compare it to what's already stored in Snowflake for those counts, those checksums. And we say, what's different? And whatever is different, we're now going to move just those blocks of data. Of course, in the beginning, everything is different. But this is a nice way to do your incremental syncing without having to know primary keys or how do you deal with rows that have disappeared. So you delete data, you don't know that you deleted it. Once you've got some log, we don't use logs. We're relying on the data to tell us what has changed. And of course, I already did mention that everything can be paused, stopped, started, brought back up. So if you need to shut it down, you can. It then goes and we'll move that data first into that file system. It does it into a Parquet format. It pushes that data up to Snowflake. And the first thing it will do is actually delete that data chunk. So if we did a group by orders table on order date, it would delete that order, that particular day of orders from the target and reload it. Now, we did that because we know either the row count or the checksum different. That tells us, did we lose some data somewhere? Did we gain data somewhere? Did anything change in the middle on something, even though the row count didn't change? But we're going to go swap that whole chunk. We target chunks in a 1 million to 3 million range because 1 million to 3 million rows is probably less than a minute's worth of processing time. That's a nice trade-off to not have to know all that other stuff and complicate matters. So it gets you to move your data very quickly. Of course, all the metrics, etc. The other half of it is, I can get the data over there. How do I make sure that the data that's there really is what's supposed to be there so that it really does match my source? So the same way we chunk that data, we also do validation on all that data. And generally speaking, we will do row count, min, max, count null, count distincts. We'll do some other stuff on we'll sum up numerics, and we'll do some different calculations on character fields to know that the data truly does tie out one for one. This might sound like it's simple to do. The problem is when you come from some other source, you deal with petabytes of data that is continuously changing. You can't shut down that source system. How do you do that and make sure it all gets there? The other problem is a source system that says, hey, this particular column's name is, value is Bob. Well, that doesn't equal Bob over here because, oh, by the way, we got a trailing space on this system. We don't over here. How do we do that? Or we don't adhere to it over here. You group by it over here, it's one answer. You group by it over here, it's a different answer. All those things get highlighted so that you know these problems early. You might have character set differences. So if you've got special characters in your data, other things, they all are going to be a problem. Other things that really can throw a migration out of whack is things like special names. So we had, again, 150,000 user tables. We got names with $signs in them, spaces, commas. They're a column name that's 150, a couple hundred characters long. So all those strangeness, all those special characters, nulls in your names, all those things were there. So we will collect all of that data. We can do that comparison. It ultimately brings it up in a view. You can go see, okay, what chunks of my data are different or not. You can then, either accept the differences, go back, recollect the data. Maybe the data has changed since you collected it. And of course, as I mentioned, everything is there in a nice report so that you can see it. So what does the actual process look like here? So of course, as I mentioned, that we're going to bring that data to Snowflake, but we don't just bring it to Snowflake. What we do is we create a golden copy that is owned by DMVA and only written to by DMVA. So it is your source of truth in Snowflake for what your source data was. You can now leverage that for everything else you want to do. We can clone from it, we can copy from it, we can incrementally sync from it because the DMVA is constantly keeping my golden copy on Snowflake in sync with my source system. And since Snowflake has time travel, we can leverage what did yesterday's data look like? What did the day before's data look like? So I can do other things with that data as well. So the idea is you're going to bring that data in, you're going to store it in that golden copy. The other nice part is that we can also now begin to do validation of every other tool that you've got out there before you've ever finished your actual ETL code conversion. You've got all those reports, you've got all those downstream consumers of data. Are they ready to go? This way you can now break that pipeline that you had to convert all this ETL code, get it all tested before you can do all this other stuff. You can make those time frames and get them to happen. As I mentioned, you do also have that ability to clone or bring that data out into whatever your testing area is. The other nice part of that is that we will build the golden copy of that data. So we will build those databases, those sync databases, I call them, that are going to be one-for-one to your source system so that your data gets brought over. If you want to transform your data, you're going to do it downstream of this sync process. But the nice part then is all your transformation is going to be post-validation. I know I got my data over right because we have all that other validation stuff going on out there. And you now have all the horsepower Snowflake gives you to convert that data, transform that data, change its names, do whatever it is that you want to do, cleanse it, straighten it, get rid of those trailing spaces, fix capitalization issues, etc., whatever the things are that would cause you some pain. By the way, in my years of experience in migrating, I strongly suggest cleaning the data before you start running your new processes. Fix it now. You've got the resources allocated. You've got the testing allocated. Get it cleaned up. Fix all those stupid little things that you've got 100 different if statements scattered through everything, trying to resolve the problem and wasting CPU cycles. If a code is supposed to be all uppercase it in the data now. Get it done. Don't make your front end have to try and uppercase it so it can do a where clause on it to find the right stuff. So, just a little tidbit. So, of course, the other part, as I mentioned, is you can do all the ETL validation. So we can bring that data in. You can reset your test database. I can say, okay, I've got a stored procedure that was my ETL process, and I want to do things like compare or load that stored proc to say, okay, here's all my inputs. They're going to be as of today. Here's all my outputs. They're going to be as of yesterday. We'll run that job and leveraging time travel to set those yesterday's stuff up because we have an incremental sync coming from DMVA every single day. So you just put that on a cycle, let it go, and let it do its thing. So of course you got to set that schedule to tie to your source system's ETL jobs to make sure it doesn't migrate the data till your source is done. You do that, you've now got a nice, easy way to go back and say, oh, hey, did that final output match my golden copy that I brought in from today on that source system? If yes, great, my code's been validated. I don't have to do a lot more. All that can be very automated and very simplify your process. So it's not just moving your data that was critical. It's, of course, validating it. It's dealing with the changes. It's dealing with all those things. And of course, that gold copy can just be tossed at the end once you actually go live. It was there to get you your data there. This is kind of a flow of the system. One of the key things we realized is that you don't want to have to sit there and start jobs and stop jobs and monitor jobs. You just want to say, hey, I want you to do 250,000 tables. Go for it. Well, guess what? When you say go for it, that takes a long time. And or something might come up in the middle. You might have to change priorities. You might have to kick a dev job in there to come up front. So we leverage a task queue, simple table in Snowflake. And that task queue purpose was that we can instantly add all the different tasks that we want to run. And these are not Snowflake tasks. These are just work to be done by DMVA. And they will sit there, they'll go in the queue, but we can change the priority of them, anything we want in there. The other nice part is all of our error handling, all of our tracking, all of the queries we run to actually execute that task are all in that task queue. So everything's there, it's easy. The entire system, once you start it, you don't need to go back to look at the VM where it's running on. Everything else is done in SQL on Snowflake. So all of your error handling, all your logging, all your reporting is all there via SQL. What this shows is that it's kind of a pipeline of things, and all these things happen in parallel. So we have unloaders happening, we have loaders happening, we have uploaders happening. We have these source measures, the target measures all happen. And the way it works is that when one thing finishes, it adds an item to the task queue for the next step in that cycle. So it moves, and all those steps are done one data chunk at a time. Data chunk, again, could be a whole table, or it might be a couple million rows in a single table. So those are all there. And finally, as I mentioned, there is a Streamlit console that you're able to see. Oh, sorry, this is not very clear on the screen, but all the things that you want to know about the system is there. You know, how fast did the work done? That top left screenshot there shows you how much work was actually done per hour of which type of task. The screen on the top right screen is how many jobs are currently scheduled. So how many have been completed and broken down by when they were submitted and what database and schema they're from. So you can kind of get a quick snapshot of, okay, you know, what's out there to be done. You can also go in and apply filters to anything. So we can go drill into that, the summary of those tasks and look deeper into it and say, okay, what tasks are actually scheduled? How long do any individual task take to run? Which ones failed? Which ones didn't? Or I can actually look and say, what's the current status of all the migrations? So, you know, what tables are in sync already? What aren't in sync? What still have work to be done on them? You know, and by that, you can go in and look at it. And it doesn't show it on here. So there might be one spot there somewhere, but we even have an issue screen. So rather than you having to know, hey, this data didn't load, what's going on? Well, the system will tell you. You know, if it can figure it out, it will tell you and say, hey, it's not loaded yet because the checksums haven't finished running on it. Or it was never mapped properly, so it didn't know where to put the data. So it goes in and tells you all those things. You then just go in, clean them up, get them submitted, and off you go. That's it from me. So hopefully this was informative, gave you some info that you wanted. You can click on that and get your QR code and get a link to be able to go and get more information on this.